When you have the same base, you can add exponents. So x to the 5th and x to the 7th, that's the same base. You add the exponents. 5 plus 7 is 12. You have the same base, x plus 3. So you keep the base, you add the exponents, you get 5. Even when it gets a little bit more strange, the bases are the same, you add the exponents. So you combine the like terms for your exponents, you get 5t plus 5. Bases are the same, 2. You add the exponents, you get 3x plus x is 4x. And then negative 2 plus 2 cancels out. So it's just 2 to the 4x. When you have a power to a power, a to the m to the n, you multiply those exponents together. So x to the 4th to the 3rd, you multiply the exponents. A power to a power, you multiply. 4 times 3, 12. X plus 3 is our base. That's not going to change. Power to a power, you multiply that. 2 times 5 is 10. Since division is the opposite of multiplying, if you divide, you'd be subtracting the exponents. When we multiply, you add the exponents. So when you divide, you subtract. If they were the same exponent, that means you have the same thing in the numerator and denominator. Obviously, your answer is 1, because a fraction, same thing in the numerator and denominator, that's 1. If the numerator is bigger, that's what this part's saying. If the numerator has a bigger exponent, you just subtract them, and that's it. If the denominator is the bigger exponent, still subtract them, but it ends up in the denominator. So that's where you had more of them. You had more of a power, a greater power in the bottom, it stays in the bottom. If the greater power is in the numerator, it stays in the numerator up top. So, same base. X to the 6th, x to the 3rd. Same base, you're going to subtract. The exponent's larger in the numerator, so that means the answer's got to be in the numerator. So you subtract 6 minus 3 is 3. Here they have the same power, the same exponent. So you have the exact same thing in the numerator and denominator. So the answer is 1. Here the power is greater in the denominator. So you subtract, and since there's more in the denominator, it stays in the denominator. The answer will be in the denominator. So 15 minus 6, there'll be 9 left in the denominator. Except with this one, I think it's actually a typo, but the bases aren't the same, so you actually can't do anything. Yep. If the bases are different, you leave it, you can't do anything to it. So the way it's written, you can't do anything, except that's supposed to be a 2. I typed it wrong. So if that was a 2 like it was supposed to be, that would be our answer. But in general, if the bases are not the same, and I'm not here to tell you that it's a typo, then you can't do anything to it. Same property. Just going to step it up a notch. The bases are the same, x and x. So we subtract the exponents. In this case, it's a little bit tough to know which one's the bigger exponent because they're expressions, they're binomials. So let's just assume the numerator is a bigger expression, a bigger exponent. And subtract 6t minus 3t when you do like terms. And then 8 minus negative 1. 8 minus negative 1. So that's really plus, you get 9. Do the same thing with this one. The bases are the same, x and x. So we will subtract 4w minus 1 minus 2w minus or plus 3. If it makes more sense for you, you can write out the whole thing as an actual algebra equation. 2w plus 3. If you do it that way, just remember that you do have to distribute the negative. So that's minus 2w and minus 3. So 4w minus 2w is 2w. And then negative 1 minus 3 is negative 4. If there's an entire expression to an exponent, every variable, every piece of that expression inside gets the exponent. So it's kind of like distributing exponents. Distribute the m to each piece, each variable. The only thing you need to be careful about and pay attention to is notice there's no addition or subtraction in that. If it was a plus b instead of a times b squared, you don't just distribute the exponent. You have to FOIL that out. That's different. You have to FOIL. You cannot just distribute the two in that case. So we have a multiplication, which means you distribute the exponent to every term inside. So that's 3 to the third and x to the third. And then anytime you've got a number with an exponent, you should multiply that out. 27x to the third. Here, the 2 is not inside the parentheses, which means you're not distributing the 3 the exponent. You're not distributing it to. It only goes into the parentheses to each variable or coefficient in the parentheses. So the 2 is going to stay a 2. X squared to the third. So multiplying exponents, power to a power, so that's x to the sixth. And then y to the fourth to the third. 4 times 3 is 12. This is my favorite property because it's the easiest. Anything to the 0 power is 1. So anything, this base to the 0 power is 1. The whole parentheses here is to the 0 power, so everything to the 0 power, anything to the 0 power is 1. The only thing to be careful about with something like this is if you had like 7 x to the 0, no parentheses involved. That 0 exponent only belongs to the x. That's it. So that would be like 7 times 1, which is 7. 0 exponent, only that piece turns into a 1. Whatever else is in the expression is still there. Negative exponents, they just flip to the other part of the fraction. So if it's by itself with a negative exponent, it ends up becoming the denominator. If it was in the denominator with the negative exponent, you move it to the numerator. You may have heard it said, hop the line and change the sign. Hop the fraction line, change the sign. So right now, it's in the numerator, you hop the line, change the sign to a positive. X plus 6 to the negative 3. Currently in the numerator, so you move it to the denominator, x plus 6 to the positive 3. And like we mentioned before, you do not distribute that 3 because of the plus sign. You only distribute exponents if it's multiplication or division. That's it. Not addition, subtraction. So this would be like foiling and then multiplying again, which we don't have to do. Here, the negative 2, you would change that to be in the denominator because it's a negative exponent. And for this one, since it is multiplication, you do distribute that exponent. That'll be 2 squared x squared. 2 squared is 4. Now it's starting in the denominator with the negative exponent. So you move it to the other part of the fraction. Moves to the numerator, just becomes 3 squared, which is 9. Same property, negative exponent, you move it to the other part of the fraction. So these are separate because they're separated by the plus sign. 5 to the negative first and 5 to the negative second. 5 to the negative first is like 1 over 5. 5 to the negative second will be like 1 over 5 squared. Still separated by the plus sign. Five squared is 25. And then those are fractions with a plus sign in between, so you can do that. Been able to do that since like 3rd grade. So 1/5 plus 1/25. You need to have a common denominator. So we can multiply this one by 5 over 5 to get that common denominator. So that's 5/25 plus 1/25 is 6/25. When you're multiplying and they have the same base, you can add the exponents. Even if they're negative, you can start with that. So add the exponents. -1 plus -2 is -3. Then, since it's negative, you move it to the denominator. And then, since you know that 5 to the 3rd, you can multiply it out. So one of the uses of all this exponent stuff is to actually make math a little bit easier sometimes, like basic math, multiplying, dividing, fractions, that sort of stuff. So here we've got some weird fraction. Maybe this started out as whatever those numbers actually were, whatever 6 to the 3rd times 2 to the 4th. It's going to simplify a lot without having to do any weird math calculations, without having to actually use a calculator and get gigantic numbers. So if you break these down to their prime numbers, 6 is not a prime number. I guess we could actually, in this case, leave it, but I don't want to. We're going to break it down to 2 and 3. As 6 is 2 times 3. Crazy. So 2 times 3 with the third to the 3rd power means that that's 2 to the 3rd power and 3 to the 3rd power. It all comes from the 6. Then we got the 2 to the 4th. That's already a prime number. We don't need to touch it. $18 is not a prime number. 18 is 2 times 9, and we know that 9 is 3 times 3. That's what 18 is. So that would be 2, 3, and 3, each with an exponent of 2, because 18 had an exponent of 2. So that's 2 squared, 3 squared, 3 squared. And then you also have that 3 to the 5th. So if you simplify this down to all the prime numbers, you can see all it is a bunch of 2s and 3s. A whole lot of 2s, a whole lot of 3s. do the numerator first. If the bases are the same, you can combine them using his exponent properties. So the 2's we can combine using exponent properties. That would be 2 to the 3 plus 4 is 7. And then 3 to the third. In the denominator, we only have that 1, 2 squared, so we'll keep that. And then the 3's, 3 squared, 3 squared, 3 to the 5th, they all have the same base. You add your exponents. Still fractions, so we can simplify that. 2 to the 7th, 2 squared, you can subtract. There's more in the numerator, so we'll keep it in the numerator. And with the 3's, there's more in the denominator, so we will subtract and keep it in the denominator, because that's where there's more. 9 minus 3 is 6. So those are just numbers with exponents. 2 to the 5th is 32. And then 3 to the 6th, that's kind of big, 729. Same idea for this next one. 5's a prime number, so you leave that alone. 10 is 2 times 5. So that's going to have a 2 to the 4th and a 5 to the 4th. And that 15, that's 3 times 5. So that's a 3 squared and a 5 squared. And then 20, there's no exponent involved, so we just have to break that down to primes. 20 is 5 times 4, and 4 is 2 times 2. So our primes would just be 5, 2, and 2, or you could say 2 squared, whatever. Now, as you get more comfortable with this, you can do a little bit more all at the same time. We don't have to do the addition first and then the subtraction. You can do it all at the same time. When you look at the 2's, we have a 2 to the 4th up top, and in the denominator, we have basically 2 squared. So if you have 2 to the 4th in the numerator, 2 squared in the denominator, you subtract 4 minus 2. You have an exponent of 2 left over in the top, the numerator, because that's where there is more. Then your 3's, that's the only 3 in the entire problem, so it stays put. And then your 5's, you look to see how much is in the numerator and the denominator, and then you subtract. Numerator has 7, denominator has 3. So you subtract, there's more in the numerator, so that's where the answer goes. 7 minus 3 is 4. So that's 4 times 625 over 9. $625 times 4 is 2,500 divided by 9. So we'll do some problems where we put everything together. A lot of the properties all in one. So just like any math problem, you would follow order of operations. So you do parentheses first, and then all of this is exponents. So we're going to deal with the parentheses first. So you're going to do you can distribute your exponent into the parentheses because it's multiplication. You can distribute that exponent into the parentheses because that was multiplication also. So that's a to the fourth, b to the sixth. And this is a to the negative fifth, b to the negative first. And then you combine anything that has the same base. So you combine your a's and then you combine your b's. We have a to the fourth and a to the negative fifth. It's like making an a to the negative 1, which means it goes in the denominator. And then your b's, we have b to the sixth, b to the negative first. Combine those to get b. 6 minus 1 is 5. All right. And you're combining all the rules. Distribute it. It's only multiplication and division going on, so you can distribute. So you get a negative 15, a b to the sixth, c to the 0 still. I'm not even going to bother writing c to the 0 because it's 1. Doesn't matter. A to the ninth, b to the negative third. The c went away because it was to the 0 power. It doesn't matter. So now you combine those. Since we've got negatives, they got to change, hop the line and change the sign. So that negative 15 comes in a to the positive 15 on the bottom. Negative 3, hop the line, change the sign. Positive 3 up top. So you have b to the ninth and a to the 24th.